Hello friends, here in this video lecture, we will understand the basic concept of stress and strain. So let's start with the stress. What is stress? It is defined as the intensity or magnitude of an internal assisting force developed at a point in the member under an external load. So here three very important keywords which we have to understand for stress. So first one is the internal resisting force. Second one is developed at a point, and third one is under an external load. So, for a better understanding, we have to take example for a circular rod, which is under an external load. Stress cannot be generated without any external load. So, stress is generated inside the material. How can we understand with this? So, we have to assume a plane which is under by stress and which is in the cross section. Okay, so this plane is has divided this circular rod in two parts, the first one and second one. Now if we assuming individually these parts, so the force is applying in the first part and second part individually, and this one is the first and this one is the second one. So how this stress will provided the resisting force inside the material to withstand at a particular force, external force, that is P. So that force is known as internal resisting force, that is capital F, internal resisting force. Here also the internal resisting force will be applied in the leftward direction, that is capital F, and this F is known as total internal resisting force offered by the plane of cross section of the bar, or we can say of the material. Okay, so to develop a equation for the stress, we have to assume a small area on the cross section. There are infinite small areas are there which are providing the resistance for the deformation. So that small area will provided small resisting force, that is delta F, and this the area of this small strip is delta A. Okay, from the formula of stress, that is sigma equals to F by A, force upon area, we have the stress generated at the strip will be sigma, that will be equals to delta F upon delta area, delta A. But this is a delta, so we have to apply the limit, that is delta A tends to 0. Why tends to 0? Because we have seen in the definition that area is the stress is generated at a point. So for to make area point, it should be tends to 0. Okay, so this signifies that delta A tends to 0. It is signifies that at a point, and we can write this equation like sigma equals to df upon dA. After applying the limits, we have the formula for infinite changes. Okay, so now by using this equation, we can write df equals to sigma into dA, and if we integrate in both sides, we have the equation F equals to sigma into A. Now we can write sigma equals to force upon area, and this force upon area can be replaced by P upon A, means force applied divided by area. How? From the second part, we can see that the leftward force equals to rightward force, because the individual part is also in a equilibrium. So F equals to P we can write. So P upon area is a stress. So stress is defined as the external force upon area on which the external force is applied. Okay, so this is all about the stress, and we can see that there are a term that is known as load. This load, sometimes students are confused that load is only the force. No, load can be anything. Like force, it can be moment, it can be torque. So let's us understand what type of the loads are there and what kind of stresses will be generated for different load. Means if we have a force, force can be the pulling, force can be pushing. So in this case, the stress is will be generated. That will be the normal stress, and the normal stress because the force is applied perpendicular to the cross section. So sigma will be written. Sigma is a normal stress, the notation of the normal stress, and it is a tensile. So sigma T we can write here. We can write sigma C. Here the bending stress will be generated, and the bending stress is the also category of normal stress. So it is denoted by sigma also, and it is a bending stress. So as a it can be written as a sigma B. If we apply a torque on a circular bar to twist the cross section, we can see that the initial cross section will be like this. After twisting, it will be like this. Okay, so the cross section is rotating in this direction, like that. So the stress generated on the surface, and the stress generated on the surface will be denoted by tau, and this is because of torque, so it is known as the torsional shear stress. Okay, it is denoted by tau T. So different stresses are generated depending upon the different type of loads. Okay, now we are going to understand what is strain. Strain is nothing but it is the ratio of change in dimension to the original dimension, and it is generated because of external load only. Okay, and it is mathematically it is written as change in dimension divided by original dimension. Since it is the ratio of dimension, therefore it is a unitless quantity. It is a vector quantity. How it is? How? Because if we are taking an example of circular bar, and this bar is going to be under a tensile loading, so we have seen we can see that its length will be increases and diameter will be decreases. Okay, so the change in length in this direction will be positive, but strain in this dimension will be negative. This is the change in diameter, it will be negative. Okay, so in this direction the strain is positive, and but in this direction the strain is negative. So we are considering the we have to consider the directions of the strain also, and we have the magnitude of the strain also. So it is a vector quantity. It is denoted by the epsilon, and it is change in length divided by original length for this condition. Okay, now we are going to correlate between make a relation between the stress and strain by using Hooke's law. It states that when a material is under a load, then the stress generated inside the material is directly proportional to the strain generated. Remember this point also. Generated, stress generated. Whenever we apply an external load on any material, that material will experience some strain and also some stress. Stress will be generated inside the material that we cannot feel. The strain can be generated, and we can see by measuring its dimensions after and before the loading. So according to Hooke's law, stress is directly proportional to strain. If we replace this proportional, then we have to replace by proportionality constant. This proportionality constant is given by the Young's, so its name is Young's modulus also, and it is also the modulus of elasticity. Unit of Young's modulus will be same as a stress because this is unitless quantity. Newton per meter square, known as Pascal also, and it is this Young's modulus is the measure of elasticity. This is very important, measure of elasticity. Now, if we reshuffle this, and we can find out the Young's modulus or elasticity modulus is the ratio of stress and strain. Okay, now we are going to see the formula for the change in length or change in dimension. If we apply a force on a a rectangular bar, its original length is LO and final length is LF, and change in length we have seen delta L. By applying this force P, or we can say it is F. For this formula we have the force that is F. So we have the formula for the sigma, we have the formula for epsilon, and we have the relation between the stress and strain, that is capital E equals to sigma upon epsilon. And we can simply put the value of stress and strain in the formula of Hooke's law. So we have the formula for change in length delta L, that is F L O upon AE. Okay, so this is the formula for change in length. Next, we are going to see a very interesting question that is asking in various interviews, and this is the very favorite question for the interviewers. So let's see, which is more elastic, rubber or steel? This is not a condition. If we are going to check which is more elastic, rubber or steel, we have to make these assumptions that the force will be same and having the both material will have the same dimensions. Okay, in this condition we can apply this method to find out which is more elastic. Okay, so this is the condition. So now I have given the hint that value of Young's modulus will give you the answer. How to find the Young's modulus value? Young's modulus value, we have the formula E equals to sigma upon epsilon. Sigma upon epsilon. We have the formula for Young's modulus is sigma upon epsilon. What is sigma? Sigma we can write out force upon area, and epsilon is delta L upon original length. Okay, by simplifying, we have F L O A into delta L. So this is the formula for Young's modulus. Okay, now we can see that if we increase delta L, now just first of all we have to understand which quantities are same for both the materials. These are force applied on both the material will be same, original length will be same, cross section area will be same because dimensions are same, only change in length will be different. Why? We know that the different material will have the different deformation when they are under same condition of load and same dimensions. So if we increase change in length, Young's modulus will be lesser. If we have the value of change in length lesser, then the Young's modulus will be more. Okay, so which will have the lesser deformation? If we say delta LR is the change in length and delta LS is change in steel material, so which is correct? Delta LR is greater than delta LS, or delta LS is greater than delta LR? Which is correct? Under same loading condition, the delta R will be more than delta LS. So this is wrong. From this, we can conclude that Young's modulus of R is lesser than Young's modulus of steel. So we can conclude that steel is more elastic than rubber. Okay, I hope all of you have understand the basic concept of stress and strain. Next, in the next lecture, we will see the curve between stress and strain. Okay, till then, thank you.